Good evening. So we are discussing the webinar number 34. Got disconnected little bit. So we will continue with our webinar number 34 on the uh, furnace efficiency. So basically we are discussing that how the furnace burner plays an important role as far as furnace efficiency is concerned. So if you can see in this case, the furnace flame is touching the wall of the furnace. The burner flame is touching the wall, which is not desirable or this is wrong. But what we can do, instead of a higher capacity size burner, we can do smaller size, two number of burners which are placed adjacent in front of the staggered. One is top, another one is the bottom line. The flame does not touch each other, and also the heating will be uniform, and there will be no deposit of combustion or combustible material on the refractories or on the wall of the furnace. So this is a correct system or an efficient furnace, whereas this is not. Now come to this. Here are the stocks, but here the flame, burner flame, is such placed in such a way that the flame is touching the product or the stock. That means it will increase the scale losses here. But in this case, what we have done, we have a little bit placed the burner at a higher position or at a higher distance or height, at a higher height, so that it will the flame does not touch the top. Here, this is a correct system. This is not the correct system. So this example shows how heat distribution plays an important role as far as furnace efficiency is concerned. Then come to third one, that is maintaining optimum operating temperature of furnace. Now we have to see that the furnace is operated at an optimum temperature. Normally, slab reheating furnace operate at 1200 degrees Celsius, rolling mill furnace operate at 1200 degrees Celsius, bar furnace for steel sheet mill 800 degrees Celsius, bogie type annealing furnace, the temperature range is 650 degrees Celsius to 750 degrees Celsius. What does furnace means? That means whenever we want to do further rolling of slab or any rolled products or any bar, we have to see that we have to preheat it so that it becomes attained temperature so that we can roll it further. What will happen if I'll operate at a very high temperature as compared to the design temperature? What will happen? If we'll operate at a very high temperature, then the more heat loss will occur, and that heat loss will be carried by the dry flue gas loss. Excessive oxidation will happen, decarbonation will happen, and that will overstress the refractories of the furnace. Refractories is a very costly item as far as furnace is concerned. Now, if the design the temperature, operating temperature is more than the design temperature, then refractories will be overstressed. So this will affect the furnace. Now, but if the temperature is low, what will happen? Why we can operate at a low temperature also? If we will operate at low temperature, what will happen? They will not get the adequate softening of the material or the further processing of the slab, rolling mill or rolled coil, billet will be difficult. So the temperature should be in the optimum range. Now, prevention of heat loss through opening. As I told you, we have studied one problem in which we have seen if the opening should not be the opening should not be opened for a longer duration. That means whenever you are putting some material inside the furnace, we should open it and immediately close it, because through the opening a lot of radiant heat loss will happen, and that heat loss is proportional to the four times of the temperature. Temperature, remember, in absolute temperature K. So what is heat loss through an opening? Q is equal to 4.88. This is a formula. You have to remember it. 4.88 T by 100 into 4 into A into H. Small a denotes the factor for total radiation. This A denotes the area of opening, that is the length and height. So this H is the number of hours. So this is the heat loss. So if the area of the opening is higher, then heat loss will be more. If the temperature is high, then the heat loss will be more. If the number of times you are opening the furnace, then the heat loss will be more. So this we have to see that the opening are minimum, and we have to close any opening as quickly as possible to prevent heat loss. Then control of furnace draft. Furnace draft is basically is an important parameter as far as furnace efficiency is concerned. What will happen? Let us say that means what is the pressure inside the furnace. What is required? The dry flue gas loss or dry flue gas should go out through the chimney to the atmosphere. Therefore, there should be some ID fan and some combustion air is required. So there should be some FD fan so that complete combustion occurs. Now, based on this, uh, there is a chimney effect because with the dry flue gas goes to the chimney, so some pressure or some pull has to be there so that this dry flue gas will exit the furnace. And also, so because of this, there will be some pressure inside the furnace. So whether it is positive pressure or whether it is negative pressure, that we will be understanding today. Now, what will happen? Let us say it is in the negative pressure. If it is negative pressure, the outside air will come. There will be some opening in the furnace. Now, if the outside air will come and it will through the opening of the furnace, because it is in negative pressure. So what will happen? This outside air is basically low temperature air. So more air will be coming. So this will give rise to excess air, due to which excess dry flue gas loss will happen. Then second one is this cold air will do non-uniform heating of the product or the stock or the blade or plate, whatever. So due to which there will be non-uniform temperature and this will affect the quality of the product also. So this is infiltration. Now what is the exfiltration? Now if you go for positive pressure, so more gas or the more heat loss will occur because the dry flue gas at high temperature will go out. So in both the cases there is some heat loss. Then what is the best way? What pressure we should operate the furnace, or what draft we should operate the furnace? That is the question. So here we have seen even airtight furnace can have air infiltration up to 40%. Neglecting furnace pressure could mean problem of cold metal, non-uniform metal temperature, which will affect subsequent operation like forging, rolling, and increased fuel consumption. So we cannot have negative furnace because it will give rise to more losses. Whereas outside air once intrudes to main, as I told you, if outside air will come inside the furnace, it will make temperature distribution uneven, and it will also oxidize the billets. But exfiltrations, that means exfiltration means positive pressures. It will result in leaping of the flames. The flame will go out and it will have some reduced peak life. Furnace maintenance, there will be some problem. The refractories will may get damaged. So, but considering in both the cases there is some losses or some difficulties or some challenges are there. But normally to achieve fuel efficiency, to conserve the losses, to conserve the make the furnace efficient, what we do, we maintain the furnace at a positive, slight positive pressures, so that it will be optimum fuel consumption will happen. How it happens? Let us discuss this one. Now there are three types of draft. One is natural draft, induced draft, forced draft, balanced draft. That means natural draft, you don't use any fan, due to gas inside the stack are less dense because it is hot in nature, so density will be no doubt will be lower and it will rise. This will create a vacuum, and when it goes to the chimney, because of this vacuum, it will draw air into the furnace. So this is a natural draft. Induced draft means in the chimney or outside the chimney, there will be some induced fan will be there, which will be drawing the this furnace air or dry flue gas and throwing through the chimney. Overdraft means there will be some draft fans will be there, which will be supplying combustion air and it will be forcing this for dry flue gas to the chimney. Balanced draft means both FD fan and ID fan will be in operations. So these are the four types of draft in furnace. Now let us see how by maintaining slightly positive furnace pressure we can have major many benefits. One is energy saving. Now positive pressure will eliminate what? Cold air infiltrations. That means it will reduce fuel consumption. The cold air cannot come in. Similarly, improved product quality because the cold air is not there. Therefore, the uniform temperature will be achieved, and that will improve the product quality. Similarly, there will be no oxidations will happen, and this will be give rise to good quality of product. Maintenance savings. So there will be also the refractories because the pressure is in positive. So there will be no major flow through the cracks and doors to the opening, and this will minimize the corrosion and crack enlargement. So there will be maintenance savings. Emission reductions. Now improved combustion control can reduce emission. So greenhouse gas emission would also reduce. So how it is achieved? You see, there is a pressure transducer is there, there is a pressure controller, and there is a damper. So based on the pressures, this damper is normally closed or open, where and its position is keeps on changing with the basis of the sensor and pressure controller. So by this we can control the furnace, and remember the furnace is normally maintained at slightly positive pressure to achieve energy efficiency. The sixth one is optimum capacity utilization. Now, always remember in case of any energy efficiency devices, we have to see that the loading is optimum. It should not be heavily loaded, it should not be lightly loaded. Now, if the furnace is underloaded, what will happen? Smaller fraction of available heat in the working chamber will be taken up by the load. That means you are utilizing very high fuel, but your useful heat taken by the product will be very low. So furnace efficiency will be low. Similarly, it receives maximum amount of radiation from the hot surface of the heating chamber. The flames are produced. Hot gas are efficiently circulated around the heat receiving surfaces. Now, stock should not be placed in the following positions. So, while putting the stock, it should not be in the direct path of the burner that we have discussed, because flame impingement should not occur. And in an area where there is a cause of blockage and restriction of flue systems of the furnace, there you should not put the stock or the product, and it should not be also placed close to the door opening where cold spots are likely to develop. The other reason for not operating the furnace at optimum loading is the mismatching of furnace dimension with respect to charge and production schedule. So we have to see that the product are particularly placed in at good optimal positions, and the furnace should be capacity utilization should be optimum to achieve energy efficiency. With this, I conclude these sessions. In the next sessions, which will continue after this, and we'll study the remaining energy conservation options available in furnace. With this, I close. Good night.